Hello, everyone. Welcome to Optimizing Industrial Operations with Digital Twins. I am Brian O'Flaherty-Wills. I'm the worldwide lead for go-to-market for AWS IoT TwinMaker. And I'm joined by Asim Kumar Sasmal, who is the Global Head of Industrial Solutions Delivery. And we're really excited to talk to you today about this important topic for our customers. What we want to talk about is four things. So first of all, I'll take us through what our customers are saying in terms of the promise of digital twins, but also what's hard and challenging about digital twins. And we're also going to set that in the context of the broader data journey that industrial customers are taking with AWS. We then want to talk about AWS IoT TwinMaker specifically and how it addresses some of these challenges and enables some of these workloads and use cases. And finally, of course, we'll show you the end-to-end workflow in the demo. So let's get into the promise and challenge. Before we go any further with digital twin, we need to speak about what is a digital twin. And this is an important topic to level set on because different customers and even different stakeholders within our customers and partners have a different connotation of digital twin. I'll say right now, it's not my role to come and say what is a digital twin and what isn't. There's lots of valid definitions. But what I wanted to do is just really level set from the perspective of this presentation, what we're talking about when we say digital twin. And so I've thrown a definition up on the slide here. There's a couple of things that I wanted to pick out and emphasize. So the first is that for this presentation, a digital twin is a digital representation of a physical system. So something that exists in the real world. And that physical system and that representation, is dynamically updated, meaning that it's hydrated with data that comes from instruments, cameras, enterprise systems, these kinds of systems that actually live and reflect the true state and behavior of the real system. The other part of this is that it's living, right? So the idea here is that industrial operations go through a life cycle. Factories and plants live on for years and decades. And so the digital twin, to really reflect that physical reality, needs to live through that life cycle and be continuously updated through that life cycle as the industrial operation evolves. So those are the kinds of parameters of digital twin, which we'll be speaking about today. We're speaking more to more customers about digital twin across industrial sectors, including manufacturing, power and utility, energy, both hydrocarbon-based and renewable, and in the building and construction sphere as well. And what's driving a lot of this conversation is really, in my mind, a coming down and a driving down of cost and complexity in a lot of the key inputs that make up digital twin. Anytime in technology, when you have inputs that become cheaper and easier, you generate new outputs. So what do I mean by that? Well, if you look at connecting data from a manufacturing environment and bringing that into the cloud and bringing that to a place where you can run analytic workloads on it, it was possible 4 or 5 years ago, but there was a lot of heavy lifting involved. Customers were creating a lot of bespoke solutions to do that. Today, we have much more maturity in our ability to securely connect SCADA equipment at scale and bring operational data into the cloud. Similarly, in AI/ML, if you wanted to train a model to predict or score an anomaly in a piece of rotational equipment, 4 or 5 years ago, you were doing that from scratch. Today, we have services that are specifically designed to target anomaly scores in industrial workloads. And the last one is in spatial. So there's been a lot of innovation in reality capture and in modeling and spatial and 3D, making it much easier and simpler to gather insights from the physical world and bring them into web applications at scale. So all of these things are happening, and customers are looking at this and saying, wow, there's more that's possible here. And in fact, we have some great examples of digital twins in industrial operations. If you haven't seen it, check out the Woodside example on YouTube that we've referenced in the past. So moving on to why. Digital twins don't exist for the sake of digital twins. There's a benefit, a business benefit to investing in this kind of technology. And what we find is that our customers are thinking about digital twin as a capability to yield outcomes for different stakeholders in the industrial operation. The way I think of it as we have stakeholders in operations who are actually governing and running the plant. We have stakeholders who are on the shop floor, who are the operators and the technicians that are maintaining equipment and processes. And then we actually have the engineers who are responsible for the process engineering, for manufacturing engineering, for improving the efficiency of the plant. And those three sets of stakeholders have three different ideas or needs around digital twin, but they really all come back to the same set of being able to look at the operation from that asset point of view. So, in the case of operations, really we're talking about things like improving asset performance, understanding asset health, root causing and correcting operational issues with data from disparate sources. On the shop floor with the operators, we're looking at how do we make better decisions about maintenance? How do we know when and how to schedule equipment service so that we can be more efficient? And with our remote experts, we have a lot of plants and facilities that are remote to the people who need to know what's going on in terms of being able to make expert engineering decisions. So bringing that 360 operational awareness to those remote subject matter experts is key. All of these fall under digital twin use cases. A really great example of a digital twin use case in action is Invista. And Invista is a customer of AWS. Invista makes is a leading global manufacturer of fiber, resins, chemical intermediates that go into a lot of our everyday objects like car, airbags, and so on. Invista came to us with a challenge of being able to connect workers on their shop floor, bring them operational data so that they can make better decisions. And they came to us with this connected worker vision from a digital twin perspective. Invista had already invested quite a bit in bringing data into the AWS cloud for operational analytics. And so when we started having this discussion with Invista, it was really important to them to be able to reuse all of that operational data in a digital twin workload and to combine that with visual scans from Matterport, our partner, to display that in a physical environment. The impact of this being improved productivity and efficiency in field operations. And so when we started working with Invista, AWS IoT TwinMaker was in a private preview form, but by reInvent, our launch last year, we were able to get to a prototype solution that really shows the value of digital twin in operations. What you see here is the Invista plant in 3D and time series data being displayed that maps to the assets on the plant floor. And so what's interesting about this is that we've got data coming from disparate data sources, live equipment data, asset information, and we've got that 3D spatial data coming from Matterport all together in a digital twin user interface. So this is really representing the start of the digital twin journey for Invista, and we're continuing that with them. So that's all good news. We have digital twins, we have increasing ease of use around digital twin, but building digital twins is still hard. And we get very, very consistent feedback from our customers around the difficulties and challenges of building digital twin. And we've kind of synthesized it into, three hard things. The first of these is pulling data from all of those disparate sources and actually mapping it into a consistent semantic relationship. So what do we mean by that? I'll talk more about that in a second, but here we're talking about data from live sources like historians. We're talking about data from transactional sources like SAP, and we're talking about spatial data. We're even talking about derived or synthetic data from AI/ML models and predictive models. All of these are different data sources. They're housed in different places. And what our customers are telling us is that it's really hard, A, to get access to all these data sources, but B, to bring them into a common context so that we can understand them all from the point of view of that asset and that operation. So that's one area where customers are spending lots of time and doing lots of heavy lifting. Once you've got that semantic model in place, the next challenge is that your operation changes. So 6 months down the road, you've added a new piece of equipment, you've decommissioned something else, your operation is constantly changing. And so that digital twin can't be static. It needs to evolve over time, and the design and management of that twin needs to adapt. And then the last piece is creating visualizations. And this is an interesting one because it kind of divides opinion. We see customers who say that, the 3D model is actually the heart of the digital twin, whereas other customers and other users find that they can get the information they need without creating a fancy 3D visualization. So the truth, we believe, lies pretty much in the middle, that there's a lot of use cases that we can serve from a 2D and even a dashboard perspective, but ultimately, most people interact with the universe in 3D. That's how we understand things. And if we want to relate all of this data from different sources to a real physical operation, we're going to want to do that in 3D. And 3D is hard because 3D is traditionally an area where there's a lot of proprietary formats, not a lot of interoperability, and not very easy to serve up at scale to web applications and to mobile applications. So that's the third hard thing. If we double click on the first of those hard things, which is all of those data sources and operations, I just wanted to spend some time on this because if you're in industrial operations, you live and breathe this every day. Just look at the different types of data that are going to be associated with a single asset, with a single pump. So, you have the properties of the asset itself, things like the make and the model of the pump, the type, the function, etc. You have transactional data associated with that pump. That's things like work orders, production scheduling, and production planning. You have the live, or if you want to call it the IoT data, that's coming from sensors, SCADA equipment, things like pressure, temperature, vibration, etc. You have the derived data, which we talked about. So that's the synthetic data coming either from models that you've trained using AI/ML or models that exist from a computational perspective. And then finally, you have that visual and spatial data. Again, we talked about 3D, but you could be talking about 2D as well here, PNID diagrams and so on. All of these are valid sources of data that you want to bring into that digital twin interface. And so really the key challenge for our customers is creating that semantic data model that understands and stores not only the relationships between the assets in the operation, but all of these associated data sources, and does it from a single API, a single query, so to speak. So we've outlined the promise and challenge of digital twin. We've outlined really some of the specific challenges around industrial operations. I want to talk about how we're working at AWS to help customers solve these challenges. But first, I want to hand it over to Asim, because one of the ways that we're helping customers to solve these challenges is by putting digital twin in its proper place along the industrial data journey. So Asim, over to you.
Thanks, Brian. Let's start with the industrial data journey. You are familiar with the traditional ISA 95 model at on-premise that consists of field and control and management levels. This monolithic model has created too many data silos, makes your data integration very difficult between machine data with over 300 industrial communication protocols, and the data from on-premises enterprise and IT systems such as ERP, QMS, MES, homegrown applications, and automation systems. That includes over a dozen, SCADA and DCS systems. The traditional ISA 95 architecture is evolving in a significant way when it comes to IT/OT convergence of Industry 4.0 using an edge-to-cloud hybrid architecture. Because of the latency and availability characteristics, it is not recommended to take a dependency on remote resources for level 0 and 1 systems that you are already familiar with. Critical level 2 systems should also be local, but you can augment additional remote monitoring capabilities so that operations staff can observe global trends. Now, it is recommended that data delays and gaps for this enhanced monitoring capability remotely should not cause any downtime to your production. Now, level 3 and 4 systems, that includes MES, ERP, PLM, can benefit from the properties of remote computing, including the ability to aggregate data from multiple sites and the ability to perform compute-intensive analytics tasks. Edge gateways are generally found in layer 3, and OT/IT gateways responsible for industrial communication protocol conversions are often found in layer 2 of the Purdue model. Now, once you have access to all of these disparate data sources in the cloud, you can now create an asset-centric data model that provides a 360 view of the asset. Now, let's zoom into the asset-centric digital twin with an example pump type of P2100. Your process engineers and reliability engineers can now query the asset data in a self-service fashion, such as locate a specific asset that has an active threat on the piping and instrumentation diagram, show all the assets of type P2100 with open work orders. The query can also be complex, such as show me assets that have increasing alarms in last 30 days with anomaly score over 80, and last maintenance was over 2 months ago for proactive maintenance, as an example. Now let's talk about the how to create a digital twin on AWS. You heard from Brian that how creating digital twin is not easy. What you really need is a modern IT/OT convergence framework. This is precisely what AWS Industrial Data Platform, also known as IDP, solution offering enables for our customers. Now, to note that IDP is not an AWS service. It is a solution offering that implements a unified industrial data backbone on AWS to maximize insights using a flexible and extensible hybrid architecture that spans edge to cloud. IDP is modular and implements a cloud-native open architecture for partners to deploy their specialized solutions on top, and thus providing a single unified data backbone for all insights. Now, on the edge side, the solution should have a secure edge to cloud connectivity blueprint that also delivers a fully functional edge with mission critical edge applications to continue running production when disconnected. Once the connectivity is set up, the solution should be able to auto ingest your machine tags or telemetry from plant floor machines across vendors and across plants. And then the solution should be able to manage the edge at scale across all of your plants. Now, on the cloud side, as the data is being ingested, you want to add context to the machine data at scale for process and machine modeling that then helps with downstream analytics. Needless to say, end-to-end governance needs to be the first priority of the solution. And then you also want to enable flexible data consumption service for external consumers, enabling insights ranging from simple observability of the near real-time KPI dashboards with actionable alerts and notifications to all the way advanced insights such as predictive maintenance, demand forecasting, inventory management, and so on. A core tenet of the solution is to provide a seamless integration with other enterprise system and other third-party non-AWS partner solutions that can sit on top of this unified data foundation as well. Now, finally, what you have is a catalog of use cases on top of this unified data foundation, and one of the key use cases being digital twin, as you see. And the last but not the least one, end-to-end security is a must-have for every customers of ours, and it is job zero for us too. And you want to have that from the get-go baked into the solution, and it's fully automated for rapid deployment at scale.
So thanks, Asim. It's Brian again. I want to talk now about having looked at the promise and challenge of digital twin and having looked at digital twin in the continuum of the industrial data journey. Let's talk specifically about AWS IoT TwinMaker and how it helps to address some of these challenges we've spoken about. I want to start with a very simple picture. This is not an architecture diagram. This is a mental model of AWS IoT TwinMaker, what it is, and importantly, what it isn't. And the first thing I want to say is that AWS IoT TwinMaker is not a digital twin. AWS IoT TwinMaker is a service that helps customers build and manage digital twins. The digital twin, as we discussed, is the representation of the individual asset or system. And so each digital twin is unique. The idea with TwinMaker is addressing some of those challenges that we talked about at the beginning of the presentation. And so how does it do that? So first, we talked about those different data sources. And when we started talking to customers about TwinMaker, we realized very quickly, TwinMaker can't be a new data source or a new data store that customers have to move data to. That's adding to the problem. That's not taking away from the problem. So what we needed to do with TwinMaker, and what we've done, is create a flexible way of pulling data from these different sources and integrating it into that semantic model that takes care of all the asset relationships and all the data properties of those assets. And so the first thing TwinMaker is going to do is help customers connect to those data sources and build that model. Now that we've got that model, we have the spatial data that we want to associate with that model. And again, here we realize that our customers don't need another way of creating 3D. There's great tools that our partners provide already, as we've talked about, for scanning, for design, things like CAD, BIM models, point cloud, etc. So it's really not about recreating the wheel there. It's about helping customers take those 3D and 2D assets that they have and bringing them into IoT TwinMaker so that they can associate those 3D models with the semantic model of the asset. And so all of that creates the digital twin. But then you have to serve this up to users. You have to create applications on the back of that digital twin. And here we realized, again, it's not a single pane of glass, because our customers have different users that we talked about earlier that have different questions and different applications for digital twin. So we knew we couldn't try to predict what our customers exactly wanted to do. What we wanted to provide our customers with is a flexible way of creating custom web applications on the back of the digital twin and serving those to users at scale. And so that is really a description of AWS IoT TwinMaker. If we take what I said and you sort of map it out from a developer perspective, this is how it looks. So we have 4 big functional pillars: data connectors, model builder, scene composer, and app toolkit to build those web applications. So what I want to do is just really quickly talk about these 4 functional blocks and how they relate to those digital twin challenges. The first is data connectors. And so we said earlier that, getting to all these data sources is a challenge. Well, data connector in TwinMaker is a framework for connecting to different data sources, bringing both the semantics of that data as well as the data itself through to an application. The way connectors work is by an event-driven system. so a Lambda. And we have in TwinMaker the ability to connect out of the box to a number of different AWS data stores that are commonly used in industrial operations, things like AWS IoT Sitewise, S3, and Kinesis video streams. But we also have the ability to let our customers connect to other important data sources that are used in industrial operations, things like OSI Soft Pi systems and SAP. So, we see this as a really powerful way, and our customers, what they really like about this is that they don't have to move their data. They can connect to those data sources where they live and start modeling the digital twin. So from the data connector, we move right away into Model Builder. And what Model Builder lets our customers do is create that semantic model of their entire operation. The way the Model Builder works is through a pattern called Entity Component. And Entity Component really comes from the gaming industry. And it's a great way of representing the real world because it allows our customers to map the entities, which are the physical systems in the plant, and the relationships between them. But it also allows our customers to describe the data properties that are important to each piece of the asset. So for example, in this example, we have a kind of a simple picture here. We have a facility, we have child entities. These could be lines. In this case, we've got pumps here. And these pumps have all of those data properties that we talked about earlier. So if we think about live data coming from sensors and SCADA equipment, that would be a component that connects to a data store like AWS IoT Sitewise. If we think about transactional data like maintenance records, that would be another component that connects, for example, to transactional records housed in AWS and Amazon S3. We can include things like PDF manuals. We can include things like AI/ML outputs, so anomaly scores. Basically, we're really given a lot of flexibility in this component framework. So this does a couple important things for customers. So number one, again, it allows us to model that physical system at scale, both the relationships between these physical systems, but also the data and the metadata coming from those different sources. What it really does is allow us to create a single common interface for all of those data sources. So once we've created this model, we can then query across it. We can find out, for example, for that pump one, give me all the pumps that have a process anomaly over the last 10 days, give me their makes and models. So again, querying across those data sources without having to know anything about the source of truth behind that. So it gives us a lot of power there. Again, it does all this without forcing the customers to move data to new systems. So this is a big benefit to our customers. Once we've got that model built, we need to tie that model into the 3D world. And so this is where we have a function called Scene Composer, where our customers can, again, use the 3D scenes that they already have, bring them into TwinMaker, and then tie them to the entity component model in this Scene Composer. So here you see on the right-hand side an example of that in a cookie factory, where we have the cookie line, we have data coming from systems that are associated with that cookie line, and we can associate that in the 3D scene to serve that up to end users. And speaking of that, the last pillar is the app toolkit. So this is where we actually get to create those front-end applications for customers and for end users, rather. With TwinMaker, what we're doing is we're leaning heavily into Grafana as a simple and effective way of bringing up web applications quickly for digital twin. So what we've done is we've released some plugins for Grafana that allow you to view and visualize the 3D scene and all of the data coming from that entity component model, and allow you to create applications on top of that. We're going to see that in detail in a few moments as Asim walks us through the demo. That's a really quick whistle-stop tour of the functionality of AWS IoT TwinMaker. What I wanted to do here is tie it back to our industrial data platform slide that Asim talked about earlier. And what I want to point out here is that if you look at that industrial data platform on the right-hand side, and if you think about TwinMaker, what it's really providing you is an augmentation on top of the data platform and giving you a way of, number one, modeling those assets, and two, it's giving you that flexible data access to create digital twin type applications, 3D applications on top of the industrial data platform. So what we're seeing here is really complementary to that data journey. What I want to do now is hand it over back to Asim to show all of this in action. So Asim, over to you.
Thanks, Brian. Let me take you through an end-to-end demo of AWS Industrial Data Platform, with TwinMaker being one of the use cases. Let's take a customer example. Amazon Smart Manufacturing is a manufacturing customer who has 4 business divisions: powertrain, stamping, casting, final assembly. For this particular demo, I'm going to dive into more in the stamping divisions, and the division has multiple sites, Chicago and Houston. Each site has multiple plants. Each plant has line, work center, sub-work center, all the way down to the machine, which is called pneumatic cylinder. And the pneumatic cylinder has a couple of measurements: air pressure, machine state, temperature. Air pressure is one of those critical temperature sensor reading that controls the functioning of the pneumatic cylinder. Once you have drawn this asset hierarchy, I kind of call this a napkin drawing, and you upload that to this magical solution called IDP or AWS IDP. The first use case that you may want to look at is monitoring your overall equipment effectiveness, OEE, near real time at the division, site, plant, line, and asset level. In this dashboard, it's the OEE for the entire division, and you have 2 sites, ORD 11 and Houston. There are 5 lines in it, so you notice the OEE for every one of them. And in ORD 11 line 1, your OEE is red because it's below the North Star 70%. And this OEE is being computed in every 5 minutes in this case for this demo. So as you notice, this particular dashboard, this actionable dashboard, can go on a monitor on the plant floor, and you can kind of browse through the historical data through it. You can check how historically your OE has been and things like that. With that said, another use case, or most common use case, is root cause analysis. Let's say you are a division manager and you are trying to look at your end of the shift, how the performance has been, and you produced 3.5 million products. Number of times the OE went below 50% is 0, which is good, but your average OE is below 70% North Star, and then it's red. And then from here, if you want to drill down further to see which particular site has a problem, you drill down to the site, and that takes you to Chicago and Houston, and you notice Chicago has a problem. Then you drill down to the plant, you notice plant ORD 11 has a problem. And then you drill down from the plant all the way to the line, and then you get line 1, which is red. And then if you drill down to line 1, you get down to your destacker. And then from there, you drill down further to your crowder. And then from crowder, you drill down to pneumatic cylinder. And the pneumatic cylinder is red because your air pressure fell down below the threshold, which is 40 to 50, and hence it's red. So it lets you kind of dive deep into the data in a self-service manner. The other use case could be forecast metrics. Let's say you have all this historical data, and you will be able to turn on something called forecasting from a reporting tool. In this case, it's Amazon QuickSight. That will be able to forecast how many bad products you're going to produce in next 7 days. it considers or gives you option to configure seasonality and everything else, but without needing any machine learning experience for a business user through this tool. Now going to the digital twin, these are just some examples that you saw, the AWS IDP platform or solution offering enables for you. Let's look at the digital twin use case. As Brian noted earlier, digital twin is nothing but a virtual copy of your physical asset that allows an operator to visually drill down to the root cause of a problem that asset may be facing, or get to know everything about that asset in a 360 view. Now let's go to the demo. What you're seeing here is a cookie factory with several machines, and there is the water pump that's supplying water to the entire cookie factory. It is getting water from a storage tank to the reservoir and then down to the cookie factory. The purpose of this digital twin is to detect a leak and generate actionable insights. There are flow meters with sensors that are measuring the water flow, and then there is the Raspberry Pi that's sending the sensor data to the cloud. There's also a camera that is continuously monitoring the pump to be able to detect the root cause of the flow anomalies. When there is a leak, the leak container is collecting water and tank will turn red. In this dashboard, you notice that as the water is flowing, the flow meter is able to detect the water flow. And in this case, now you are going to basically simulate the leak. What you will do is you close the valve 1, but you open the valve 2 that's collecting the water in a leak container. And as soon as it detected leak, you'll notice that the pump will turn red. And if you click on the red icon there, it's going to take you to the dashboard again to show you that I've detected a leak, and your flow meter is able to detect the flow in the leak container. Now, if you click on the video tag, and you remind that like what exactly happened, the camera took a video and it's able to tell you that somebody kind of created a leak in this case. Now, going back to what enabled this particular use case, if you kind of look at the architecture at a glance, in a real industrial setup, your data comes from industrial devices. There is a edge which collects your data. In this case, the services were AWS IoT Greengrass. And if you need a protocol conversion, you will do that. Your data was sent to cloud with AWS IoT Sitewise. And there is a Kinesis video stream, Amazon Kinesis video stream. And then there is your Amazon S3, which is the data lake. And then finally, TwinMaker basically enables the digital twin by bringing all the contextualized data together in one place. With that said, let me hand over to Brian.
Thanks a lot, Asim. Before we conclude, I just want to make a quick plug for some of our launch partners. We have a great group of partners for AWS IoT TwinMaker that really complement the service and help customers create value from TwinMaker. We have partners who do ready-made solutions that help you get started and really deliver digital twin outcomes quickly. We have a great group of system integration and services partners, and we have a great group of partners who provide really interesting data inputs from the perspective of modeling and simulation, visualization, great data inputs to build that digital twin. So these partners are listed here. They're also on our website. I don't have the time to go through them all, but really encourage you to take a look and reach out. So to wrap up, I want to offer some ideas on how to get started. Hopefully, in this presentation, we were able to kind of give you some insight on digital twin, what our customers are excited about, what they're challenged with, how digital twin maps to the overall data journey, some of the functionality of AWS IoT TwinMaker, and hopefully a concrete idea of what this is all about from that demo. What I want to offer now is just some ideas on how to get started. So if you want to just dive deeper, you can get started right away with the AWS IoT TwinMaker. It's free to use in preview, and we have a great getting started tutorial on GitHub that allows you to build your own cookie factory, like the one you just saw. So encourage you to go ahead and do that. And if you want to take the next step and you're thinking about digital twin in your operational environment, you can reach out. Go and click that link. We'll share that link with you, and we're happy to help engage and plan that proof of concept. You can also reach out directly to either Asim or myself. We've got our emails right there. We'll share our LinkedIn details. So with that, I want to thank everybody very much for your attention. Asim and I are both going to stay on here to answer questions in the chat. Really appreciate your participation, and I look forward to your questions.